Hello everyone, in this video we are going to discuss about splicing. The transcription of eukaryotic gene results in the formation of pre-RNA. The pre-RNA has coding sequence and non-coding sequence. Coding sequences are exons and non-coding sequences are introns. Splicing is a phenomenon in which introns are removed and the exons are joined together to form a mature mRNA. This is the picture of pre-mRNA. Here we can see coding sequence as well as non-coding sequence. In the mRNA, the introns are removed and the exons are joined together. The part of intron towards 5' end is known as the 5' splice site. The part of intron towards the 3' end is known as the 3' splice site. The exon towards 5' end is known as the 5' exon, and the exon towards the 3' end is known as the 3' exon. 5' splice site and 3' splice site are marked in this picture. We can also see 5' exon and 3' exon. The phosphodiester bond between exon and intron at the 5' splice site is first broken, and 3' hydroxyl group of the 5' exon reacts with 3' splice site to complete the reaction. This is the mechanism of splicing. In this picture, we can see the broken phosphodiester bond. 3' hydroxyl group reacts here. Next, we can see the types of splicing. First, group 1 splicing. Group 1 intron can hold a guanine nucleotide. The 3' OH group of the guanine nucleotide reacts with the 5' splice site, and the guanine nucleotide finally attaches itself at the 5' end of the intron. This attachment of the guanine nucleotide makes the 3' OH end of the 5' exon free. The 3' OH group of the exon then reacts with the 5' splice site. This joins the two exons and releases the intron, completing the splicing reaction. Group 1 splicing is also known as self-splicing, as no other proteins are involved. Next, we can discuss about group 2 splicing. The splicing of group 2 introns can either occur by self-splicing or with the help of other proteins and RNA known as the spliceosome complex. Group 2 introns have an adenine residue in the sequence. The 2' OH group of the adenine reacts with the 5' splice site and forms a loop-like structure called lariat. This reaction makes the 3' OH of the 5' exon free. The 3' OH group of the exon then reacts with a 3' splice site, which releases the intron and completes the splicing mechanism. Next, we can see group 3 splicing. Splicing of group 2 introns can also be mediated by other proteins and RNA, which is known as spliceosome. This complex consists of 150 proteins and 5 RNAs known as small nuclear RNA or snRNA. These 5 snRNAs are designated as U1, U2, U4, U5 and U6. In the first step, the snRNP U1 binds the 5' splice site. Next, U2AF, also known as U2 auxiliary factor, binds the 3' splice site. U2AF further helps other protein known as branch point binding protein to bind the branch site. The branch point binding protein is further displaced by U2 snRNP at the branch site. The adenine bulges out. Next, U2AF is released and U2SNRNP further recruits U5, U4 and U6 SNRNP. The U6 SNRNP tries to occupy the U1, hence U1 is released. The U6 then tries to interact with U2. During this interaction, U4 is released. The interaction between U6 and U2 triggers two reactions. First, there is a formation of lariat by 5' splice site and adenine at the branch site. Second, there is a reaction between 5' splice site and 3' splice site, completing the splicing reaction. Next is alternative splicing. Alternative splicing is a process by which the exons of the RNA are reconnected in multiple ways during RNA splicing. The resulting different mRNAs may be translated into different protein isoforms. Thus, a single gene may code for multiple proteins. Stability. Stability of mRNA is an important aspect that affects the gene expression. Long-lived mRNA can undergo multiple rounds of polypeptide synthesis. Short-lived mRNA degrade rapidly and cannot undergo multiple rounds of polypeptide synthesis. Thank you everyone.